All right, so graphing exponential decay. Today's process is identical to yesterday's process. There is one minor difference. In fact, if you look at the problems, they are identical to yesterday's problems, except for one minor difference. This says 1/2. Yesterday it was 2. This one was -2. Today it's -1/2. This one's 1/5. Yesterday it was 5. This one was 2 to the x plus 3. Now it's 1/2 to the x plus 3. It's literally the exact same notes except for one major difference, which is what? What's a fraction?
A.
That b value, because exponential decay has a multiplier that's between 0 and 1. Now, that does not change a darn thing about the way we graph it, other than the fact that when you plug stuff into your calculator, you're going to have to plug a fraction in. That's the only thing it changes. Now, your graph will turn out slightly differently. Remember yesterday? How could you tell from a graph that it was growth?
That is going away from that.
It's moving away from the asymptote. Decay is the opposite. It's going to be moving towards the asymptote. Okay? So let's see what this looks like. We're going to start with 1/2 to the x. Where's my calculator? So, again, we have an h value of 0 and a k value of 0. H determines what goes on here, just like yesterday, right?
Yeah.
And k determines what goes on with your asymptote. So my asymptote is at 0. So I'm going to plug in values. Now, whenever you plug in a fraction, do you notice the fraction is written in parentheses in the problem? Make sure you plug it in parentheses. So parentheses 1/2 to the -2nd power is 4. Why is that 4?
Because if it's to the -2nd, it's 2. Right?
If it's to the -2nd, that's going to be 1 to the -2nd over 2 to the -2nd. And to fix those negative exponents, you got to move the 2 to the top and the 1 to the bottom, and that gives you 4 over 1. So fractions, when you raise them to negative exponents, end up flipping. All right, so 1/2 not to the -2nd, but now to the -1st. Any guesses? 2. 1/2 to the 0. 1, because anything to the 0 power is 1. 1/2 to the 1st is 1/2, or 0.5. Right? I think that decimals in your XY chart are easier to bring over to the graph than fractions are, FYI. And then 1/2 to the 2nd is 1/4, which is 0.25. All right, let's graph it. -2, 4, -1, 2, 0, 1, 1.5, and 2.25. Can I cross my asymptote?
No.
No, never cross your asymptote. Again, your asymptote is still y equals k. What's my domain?
All real numbers.
What's my range?
Y is greater than 0.
Exact same process as yesterday, but do you see how as you move from left to right, you're getting closer to the x-axis or closer to your asymptote this time? Easy peasy? So if you did good on yesterday's stuff, today's going to be a piece of cake because it's the same thing, right? If you didn't do so hot on yesterday's stuff, now's your chance to make sure you got it because it's the same thing basically.
So
Yes.
decaying, if it's decaying, B will always be a fraction.
I'm not going to say that to know it's decay that B is always going to be a fraction because there are fractions that do not meet this requirement.
Okay, so just always look at the graph.
B always has to be between 0 and 1. Because if your B value is 5/2, that's a fraction, but that's exponential growth because 5/2 is bigger than 1.
Yeah,
Okay? So don't get hung up on that whole, if it's a fraction, it's decay. I can't remember, but in the past we've had on the test, I'll give you like 5 equations and just ask you to write growth or decay or neither next to them. And inevitably, whenever we do that, there's always one that has a fraction that's like 5 halves or something like that, where it's trying to catch those people who look at a fraction and say decay, even though it's a fraction with a value greater than 0, or greater than 1. All right? Questions about that? Yes. What would be neither? Good question. This is technically neither because it's exponential growth reflected. If it's a reflected one, it's technically neither. Something in y equals mx plus b form would be neither. Y equals x squared would be neither. Because we know that y equals x squared is a parabola. It's not an exponential function. So in order to be an exponential function, you have to have an x in the exponent, and it can't be reflected. We don't want it to be reflected. Okay? All right, so do you want me to do all these guys for you?
Not really. If it's the same, not
Well, they have to study.
It's the exact same stuff. Let me do the last one with you, just because that one has an a value, an h value, and a k value, just to make sure that you know what you're doing with it. Okay? All right, so what's my b value? 1/2. By the way, b is known as your multiplier. Yesterday it was also known as your growth factor. Today it wouldn't be a growth factor, it would be a decay factor. No brainer. What's your h value?
negative 5.
That's going to tell me what?
How far where the center is.
Nope, that tells me where my center is, so that's going to go here. And then what's a?
6.
What's k?
-2.
That's going to tell me what?
That's where it's going to be asymptote.
Yep. So, there's no place to write my asymptote, but my asymptote is y equals -2. What's my domain going to be?
All real numbers.
My range is going to be y is either greater than or less than -2. Can anyone tell me if it's going to be greater than or less than?
It's greater than,
How do you know?
because it's not a negative a.
Because it's not a negative a. Thank you so much for saying it's not a negative a and not just saying, because your asymptote's at the bottom, how are you going to graph below it?
I got you.
Okay? It's because your a value is positive. So my graph is going to be up here. So I have my starting point. I'm going to fill in some values around. Yeah?
Yeah.
And now I'm going to go to my calculator and start plugging stuff in. So 6 parentheses. I could use the fraction button. 1/2 in parentheses to the. Do I need to put x plus 5 in parentheses?
Yes.
Because my calculator didn't open a parentheses for me, but I need to put it. So that way my calculator knows the difference between what's an h value and what's a k value. And I get 22. Again, exponential growth, you're going to get a value every now and then that is just way out there. Okay? Now I'm going to change that -7 to a -6. And I get 10. Now I'm going to change it to a -5. And I get 4. Now I'm going to change it to a -4. And I get 1. And now I'm going to change it to a -3. And I get -1/2 or -0.5. Questions about what I did there? All right. -722, there, I'm not graphing that high. That's way too high. -610 will fit. Will fit on my graph right there. -5, 4. -4, 1. And -3, -0.5. Now, this graph is a little different than the other ones because the other ones, remember, I always had those points that were really, really close to my asymptote. This one, I don't really have a point that's really close to my asymptote, do I?
Right.
I would have to go out further. Am I going to make you go out further on your XY chart? No. You just need to know when you're graphing this, even though this is close to -1, don't mistake that your asymptote is -1, because it's not. It's -2. So it will still go down a bit further, like that. Okay? Now, since I have a little bit of extra time, actually, let me finish this one first. Transformation, what did that 6 mean? I have a...
Vertical stretch of 6.
I've trained you guys well. I have a shift how?
Left 5.
Down 2.
And a shift down 2.
Happy second.
Now, before I let you go, there's a couple things that I want to address. These are common things that I see and they drive me nuts because there are some people that are just so anxious to get done with their graph that they aren't careful with their graph. So they will be graphing, and I'm not going to do an XY axis, but here's your asymptote. Say that's your asymptote. And they'll be like, oh, it goes like this.
Oof.
Problem.
Does it go up?
You don't understand what's going on if you're being so lazy that you make it go back up. You have to just intentionally make it kind of level out there. This right there tells me that you're too lazy to show that you know what you're talking about. Okay? That absolutely drives me nuts, and I get it all the time. Okay? You also have to make sure that you're not doing that,
You don't want to cry.
because that's a huge no-no. Unless you're Casper, you're not going through the asymptote. Right? Okay? So just be aware of that. Don't sit there and try and so quickly get through the graph that you're making lazy mistakes like that, because it really does change what you're showing me that you understand. Okay? All right. Happy studying.
Happy second.